Okay, we're going to get started with intro to data visualization today. And how today is going to go, I have about a 20-minute slide deck to cover sort of basics of data visualization and why we choose the kind of visualizations we do. And then we'll switch over to our R component. So you all should have gotten an email this morning with an R file and a .csv, which is a data file. So we'll pull those into R and we'll work through some examples with ggplot, which is R's primary package for making data visualizations. All four of the visualizations on the screen right now were made using ggplot, and we'll get some practice in how to code. And we'll walk you through all of it, Elle and I, so don't worry if you've never used R before, we will figure it out together. So we'll start with what data visualization is. It's a way to represent our data using visual tools that help us think or understand, and it particularly uses our perception or our visual system of our brain. And we use this because our brains are faster at understanding images than they are at reading numbers like you might in a table. We're going to cover two main steps to making a good data visualization today. Step one is to pick the right graph. And step two is to design that graphic to highlight important information. And our goal with all data visualization is to tell the data's story. And you can see an example at the bottom. We have our data table, which if you just glance at it with our human brains is a lot of numbers and it's hard to pull patterns out. But we can use data visualizations like the one on the right to start to take a look at our data in a way that's easier for our brains and people who we want to communicate with, easier for their brains as well. So we have two main goals we use data visualization for: exploration and communication. So for exploration or data visualization for exploration, the audience is typically yourself or your colleagues in your research group. It helps you get to know your data, to look at the distribution of your data, to catch data quality issues, to see unusual points, which in statistics we call outliers, so unusual values that you don't expect. And it can help us start to identify relationships within our data as well. We also use data visualization for communication, where you want to communicate to some audience, which might be your boss, it might be fellow scientists, or it might be the public. And so when we start to think about communication, we want to think about what context our audience needs in order to understand the information we want to share. And when we're trying to communicate, effective graphs do a couple of things. One, they convey information without distorting it. Two, they're simple and easy to understand. Three, they use aesthetics like color, texture, and shape to support the message you're trying to share. And four, they're not overloaded with information. And lastly, the most important thing we want to do, whether we're using visualization for ourselves or for others, is tell the truth about the data. And we'll get more into that later. So a little note on design and perception before we start going through the kinds of graphs you can use. Human brains are super skilled at some kinds of perception and really bad at others. We tend to be very good at differences in color, length, and location, but are less good and actually very, very bad at things like area and angles. And to demonstrate this, we have two images down below, and I'm going to ask you to look first to the left at the two circles. And if you would mind typing into the chat for me how many of the little circle you think you would need in order to cover the whole big circle. And I'll say that again, type into the chat, if you look at the big circle, how many little circles you need to cover that big circle. All right, we've got numbers flying in. We have numbers like 5, 6, 7, 8, 10, 20. And then we're gonna repeat, we're gonna do that again, now looking at the rectangle and the little square. Same question, type into the chat, how many of those little squares do you think you need to create a rectangle as long as that long rectangle? So I see 6, 7, 8. Yeah, 5, 7, 8. Great. And so here's our demonstration. If I cover them again, both of these actually require 7. So we have 7 little circles and we have 7 additional rectangles. And this is to demonstrate, if you noticed in the chat, we had a much wider variety of numbers for how many circles, whereas for the rectangles, people were pretty close to 7 with about 6 and 8 as the estimate. So keep this in mind as we go through and talk about different kinds of graphs. We want to make sure we're using tools that people are good at understanding, like color, length, and location, and trying to avoid tools people are bad at, like area and angles. So we'll start talking about types of graphs, and we're going to start with graphs that help us look at the distribution of our data, by which I mean how our data is spread out or concentrated. And we use these types of graphs to look at one variable at a time. And we're going to start with looking at one continuous variable. And when I say a continuous variable, I mean a variable with a number or a count, like the number of mosquitoes, which go 1, 2, 3, 4, 5, etc., or something like a temperature, where you have a range of numbers a temperature can be. And we have two main plots we use to look at continuous variables or number variables. We have histograms on the left, which is a way of looking at how many times in our data we saw a certain number. So in this graph on the left, if you look along the x-axis, the bottom here, I'm looking at the number of Culex torsalis females, that's a species of mosquito, that I trapped during my study. And we can look at what these bars, which I would call bins, and these tell us how often we caught that number of mosquitoes. So if I add a highlight here, each of these bins I've set to be a width of 5. So this first bin tells me we trapped between 0 and 5 females about 200 times. And if I go to this next bar, that tells me we trapped between 5 and 10 mosquitoes. I'd say approximately 130 times in our data, and so on. And so what histograms are really useful for showing us is what the most common values in our data are. For this, it's pretty clear that we mostly trap small numbers of these mosquitoes between 0 and 5 or 5 and 10. I mean, only very rarely, we have 1 or 2 bars out here, we very rarely trap these large numbers of mosquitoes. They can be helpful for highlighting outliers, again, these unusual values out here, any unusual patterns or any gaps you might see in our data. The other option we have for looking at one continuous or number variable is a box plot, which is something of a summary of the information in our histogram. So these two plots are done on the same data, but what a box plot does is give me a little bit more of a summary of the data. It highlights our median, this thick black line here, our median or our middle value. It shows me the range of most of the data here in this light blue. And then it shows me where all my outliers are, all of my unusual values out here. And box plots are useful for showing you your outliers, for letting you know if your data is symmetrical or not. You'll see our data is pretty asymmetrical. We have our median is very far to the left, and then we have this long tail or long spread of unusual values. And you can use histograms and box plots together. They show you slightly different things about the same data. And we'll go ahead and move forward to a different kind of variable in our data, which is categorical variables. We're still looking at distributions, how our data is spread out. But this time we're looking at a kind of data that comes in categories. So our example here is species, where we have some number of times we've trapped Aedes aegypti, we've trapped Culex pipiens, and we've trapped Culex torsalis. All of these are mosquito species if you're unfamiliar. And when we're looking at categorical variables, we want to use bar plots, which is this plot on the left, which shows us which groups have the most and which groups have the least. So on our x-axis, again, we have one bar for each species that we caught. And on the y-axis, we're counting how many times we caught that species. And if we look at this, we can see we caught Culex pipiens the most often, and we caught Aedes aegypti the least often. And you can put your bars side by side like I've shown here, or you can also stack your bars and just have the colors differentiate the different species. Now, you may also be familiar with another kind of chart to do this called a pie chart. And a note here, I've quoted Dr. Cole Knaflick, who wrote a brilliant book, Storytelling with Data. This is a direct quote from her book. Pie charts are evil. Humans are bad at perceiving area, and you should use a bar plot instead. If you look at this pie chart, again, run on the same data as this bar plot, you can see it's actually really difficult to tell the difference between Culex pipiens and Culex tarsalis here, whereas the difference is very clear in the bar plot. So please keep in mind, pie charts are evil. I am a certified pie chart hater. We're bad at perceiving area, so you should be using a bar plot instead. Now we'll move into looking two variables at a time so that we can look at relationships between variables. And graphs like these help us answer the question, are two variables related? And we'll start with two continuous variables, or those number variables I mentioned, where you might have one mosquito, two mosquito, three mosquito, and you might have a range of temperatures you're interested in looking at. And for this kind of data, we typically use scatter plots. And in these scatter plots, if you look on the left, I'm looking at temperature along my x-axis, this horizontal axis at the bottom. And I'm looking at the number of mosquitoes, again, Culex tarsalis, that I caught on the y-axis or this vertical axis. And the way scatter plots work is each combination of a temperature and a number of mosquitoes that I have in my data gets one dot or one point on this graph. And I've additionally added a trend line or fit a linear model through the data so we can take a look and we can see that on average, as our temperature increases, the number of mosquitoes we've caught has also increased. So scatter plots help us look at what the shape of the relationship is and also catch any outliers in the relationship as well. You can see we have a couple of these really high catches in this really high temperature bin. And I've added the graph on the right to show you that not all relationships are linear. If we look now across collection date or across the season on the x-axis, we can see that we tend to catch the most tarsalis females in this August to September timeframe, and then our numbers begin to drop off. So this is a note to remember to take a look at the shape of the relationship. It might not always be a line. Now, if we want to look at categorical variables, again, these variables have categories like the species, or here we're also looking at the type of trap we used. We can look at these in combination together using something called a stacked bar plot. So this is a similar bar plot to before, although now on our x-axis, we're looking at the type of trap that we used. And on the y-axis, we're now looking at how often we detected each species. And we're using the color of the bar to denote which species we've trapped. And we can use this to see that we tend to catch relatively equally in BG sentinels, these three species. But if you look at gravid traps, we catch much more Culex pipiens than we do Aedes aegypti or Culex tarsalis. So stacked bar plots are great for showing frequencies, showing the combinations of how often we trapped Aedes aegypti in BG sentinels versus how often we trapped Aedes aegypti in carbon dioxide traps. And this kind of plot is nice because it shows us how often the traps themselves are used. You can see in our data we have very few backpack traps and mostly BG sentinel traps. Another option for two categorical variables is a percent stacked bar plot. This is the same data again as in this plot here, but this time we're looking instead at the percent of time a species was caught in each of these trap types. And the nice thing about looking at this percent is that we can actually see how often each species was caught in backpack traps because we're looking at 100% of the catches in the backpack instead of looking at the numbers, which means since we only have a few backpack traps, we can't really see what's going on. This also makes it easier to compare between trap types. And again, we can see a really interesting finding, which is that we tend to catch Culex pipiens in gravid traps more than we catch the other two species. Both of these types of graphs are useful It just depends on whether you want to compare between the different kinds of traps or whether you want to compare but also see how often each of those traps were used. Another option, combining now our categorical or our category data like species with our continuous or our number data like the number of mosquitoes, is we can bring back our box plots, but now we can compare box plots between species. So I have now a box plot for each species here, Culex dorsalis, Culex pipiens, and Aedes aegypti. And this helps us answer some questions about the shape of the relationships. We can see we tend to catch large amounts of Culex pipiens way more often than we catch large amounts of the other two species. And you can notice that we tend to catch very small amounts of Aedes aegypti compared to the two Culex species. And it can again highlight what categories or what species have more outliers than others. And this is a note to say there are many other cool graphs. That was a quick run through of some basic graphs that you can use to look at your data, but there's lots of other options. And just to give you a quick overview of a few other options, we have this wireframe plot on the upper left, which is a way to look at 3 variables at once. In this graph, along the bottom, along this axis here, we're looking at the number of days since a mosquito has fed. We're looking at the temperature the mosquito is living at. And then what we're predicting here, this upright axis, is the probability of that mosquito being able to transmit a virus. And this lets us look at the effect of the number of days since they've fed and the temperature in combination. And you can see if you look at this plot that a mosquito becomes able to transmit much faster at high temperatures than at low temperatures. Another option you can do is you can map your data. Here in the bottom center is an image from a paper of mine we're working on where I've used data visualization to show where certain areas were that did meet our inclusion criteria, aka that we could include in our study, and where there were areas that we were not able to include in our study. You can also do something like a heat map, which is another way to display 3 variables. Here I've again looked at the traps along the x-axis, trap types, and the species along this upright y-axis here. And then we can look at how many total were caught in each combination of trap type and species. And this is just truly a broad overview. There are many more types of graphs than this. And in the last bit of the slide deck, I have some resources of catalogs that are data visualization catalogs where you can click through and look at different ways to visualize your data. So now that we've done a brief overview of types of graphs, we're going to spend the next bit of this seminar talking about how to make design choices that better the impact of your graph. So a reminder again that effective graphs convey information without distorting it, are simple and easy to understand, use aesthetics like color, shape, and texture to support the message, and are not overloaded with information. And lastly, the most important piece is that they tell the truth about the data. On the right is an example of using design to increase the impact of your graph. This is again from Storytelling with Data by Dr. Knaflic. In the upper right, you'll see a relatively plain graph, but in the bottom right, we've now used this additional dashed line to mark where the average is, and then use color to highlight where the cost per mile is higher than average. And this helps the reader focus in and center in on the important information you want them to know, which is that drivers driving a smaller amount and drivers driving a much higher amount tend to have higher cost per mile versus drivers driving this middle amount per month. So first step is do not distort the data. And this may seem like a silly thing to add, but it's shockingly easy to make your data look large or insignificant depending on how you shape your y-axis. So if you'll look at this graph, we're looking at the differences in salary between female academics on the left and male academics on the right. And you'll notice that this looks like a really large difference. But I want to draw your attention to where the y-axis starts. Our y-axis starts at the bottom at 77,000 and goes up to 82,000. And so if we expand our y-axis so it starts at 0 and we get sort of a true understanding of the range of the data, we can see that the differences between female and male academic salaries do not look as extreme. And a couple other examples of this. On the left is a real graph that was displayed in the news. I think this is in 2012, so it's kind of old news, but you can see that it looks like if the tax cuts expire, the tax rate is going to go up almost 5 times as much. But again, our y-axis here starts at 34. And if we move our y-axis to start at 0, the difference doesn't look so extreme. And one more example, this line chart on the right, you can see if we limit our y-axis, this looks really volatile. But if we expand that y-axis to its full range, we see that it's actually a relatively stable number. So paying attention, both when we make our own graphs, we typically want the y-axis to start at 0 unless you have a really good subject matter reason not to. And also paying attention when we read other people's graphs, whether that's in the news or in presentations or on posters, to make sure that you're catching what the y-axis range is. Next, we're going to talk about using color to highlight things in our graph. And there's a couple different ways we can use color. The first is what's called a sequential color scale, where we're going from dark blue to light blue. And we tend to use this kind of color scale for those number variables we've been talking about, like the number of mosquitoes, where we go from 0 to 1 to 2, all the way up to, say, 55. We want to use sequential color scales when you want to show low to high patterns. And you can see an example on the right. We're looking at Culex tarsalis caught per trachnite across California in 2023. And you'll see from green, we have 0, all the way up through yellow to red, we have about 180 mosquitoes. And this lets you intuitively read this graph to know that green areas tend to have lower numbers of mosquitoes, and more to yellow and orange areas have higher numbers of these Culex tarsalis mosquitoes. And I wanted to add a note to use colors that would be intuitive for your readers. To a Western reader, red tends to read as hot or high, and blue tends to read as cold or low. So before you pick a color scale, be thinking about what colors would intuitively support the information you're trying to show. And a note also to use colorblind friendly palettes. Color blindness is relatively common, and so if you use color combinations like green-red, that can be really difficult for some readers to see. And I have resources on the last slide for finding colorblind friendly palettes. We also have a kind of color scale called diverging, where we have a middle value and we want to show numbers that fall below that middle value compared to numbers that fall above that middle value. Our example might be a tick density above or below average. And we want to use a diverging color scale when we want to emphasize the extremes of our data, when we want to show differences in the data, or when your middle value, this white value in the color scale, is a meaningful number. And our example on the right is also from my own work, where I've used a diverging color scale because the middle value is meaningful, because I want to look at how much infection rates are changing in my 2 species, and 0% change means that our treatment had no effect. So that's a really meaningful number. And then I have this diverging scale where it becomes more red if the infection rate is increasing and more blue as the infection rate decreases. So again, we're using it because our middle value is meaningful. There's no change around day 7. And because I want to show these extremes that infection rates tend to increase for a while and then start to drop off over longer time scales. Our last color scale is for categorical data, categories like what species of mosquito we're looking at or what type of trap we're looking at. And for this, you want to make sure you're using very different colors for each category, so it's easy for the reader to differentiate between your categories. And I've added a note here as well. Hopefully you noticed this through the presentation, which is you should use the same colors for the same variables throughout. So throughout this presentation, I've used dark blue for Aedes aegypti, olive green for Culex pipiens, and this light pink for Culex tarsalis. And this helps the reader as they flow through your paper or your poster, keep track of the same variables and understand that all the information is connected. We can also use color to highlight. We have on the left the same example from the beginning of this section, and on the right, a long string of numbers, where if I asked you to count all of the fives in that string of number, that would be pretty difficult. But if we highlight the fives in a different color, it suddenly becomes much easier to find them. So we can use color to highlight specific special information we want the reader to look at. We can also use things like texture and shape. And when I say texture, I usually mean texture of lines, as in a solid line or a dashed line. In the upper right, I've used dashed lines to tell the reader that that information was predicted from the model, not observed in the data. And I've used solid lines to tell the reader that that was the information that was observed in the data. You can also see in the bottom right, using shape to identify species. I have triangle for Aedes aegypti. Oh, no, triangle for pipiens, sorry. I think circles for Aedes aegypti and squares for tarsalis. And texture and shape do a couple things for you. They make sure that your graph can be viewed in black and white, so even if the color information is removed. They can help make graphs more accessible to colorblind people, and they can let you add layers of information. If you're using color to say one thing, you can then use texture to say another thing alongside color. And then lastly, we'll talk a little about labels and annotations. Ideally, your graph plus its caption should stand alone, by which it means it should contain everything your reader needs to know to understand the graph. And I've highlighted in this graph a clear short title that tells the reader what the graph is about. And each axis has its own label. So our x-axis is mean daily temperature, and our y-axis is the Culex tarsalis females caught per trap night. And you'll notice that I've highlighted that you should include units. So daily temperature is in Celsius. So I've added the C at the end to let the reader know that this graph is in Celsius, because 10 to 25 degrees Celsius is a very different range of temperature than 10 to 25 degrees Fahrenheit. A couple more examples of annotations. In your legends, you want to make sure you have informative labels. Here I've said exactly what each scenario is, and not just said scenario 1, scenario 2, which doesn't tell the reader anything. And you can also use annotations to guide attention. So I've added this dashed line to show readers when our first treatment was applied to this area, so that they know that things before that dashed line happened before treatment, and things after that dashed line happened after treatment. Lastly, we want to limit chart junk and keep our charts as simple as possible. You can see in the chart on the left, we have this blue textured background, we have three-dimensional bars, we have a photo of blueberries, and it all adds up to a lot for the brain to take in. Whereas the same graph redone on the right, we've removed the background images and texture, we've removed the three-dimensional bars, means that it's very easy to see which breakfast food has the lowest calories per serving. And we can also now use the color red to highlight that bar as well, because we don't have all of these extra colors like we do in the graph on the left. And one last quick note is you also typically include a caption with your figures. Again, figures should ideally be standalone, meaning a viewer can understand the finding without reading your main text. And a quick look that captions should include a couple things: a declarative title that tells you a summary of the findings. You should briefly describe the methods needed to understand the figure, and then include any statistical information relative to the figure as well. these are a couple resources that I really recommend. The book Storytelling with Data by Dr. Polnaflik is a great guide. It's actually written for businesses, not researchers, but all of the information is equally as relevant to us. It's a pretty quick read and very easy to read. There's also this data visualization catalog, which shows you graph options organized by function. So you can tell it, well, I want to look at graphs for looking at relationships, and then it will show you literally dozens of graphs that you can use to display relationships. For looking at color palettes, both of these resources include colorblind friendly options. We have this website, Color Brewer 2, that lets you point and click to choose color palettes. And then we have my personal favorite color palette package for R. There are lots of them, but I like SciCo, which stands for Scientific Colors, the best. And that's what we'll be using at our demonstration today. And then I also recommend this R Graphics Cookbook, which has clear, easy recipes for making plots in R. And my next slide is a thank you slide, but I'm going to leave these resources up so people can take a look at them. And I do see things happening in the chat. I see a second person saying Storytelling with Data is a great book, so I love that. And then additional colorblind friendly palettes from Iris, thank you. So I think, Olivia, it looks like you were about to say something.
I was going to tell you that I was going to tell you what you just read. So
Brilliant, perfect. Okay, we're at 11:35, so I think I have time to take maybe one question if people want to type a question into the chat, and then we'll transition to the R portion of today's workshop.
I'll just mention I'm sending a link. I put the files that were in the email in a Google Drive folder in case anybody didn't get that email. So you should be able to access them there.
Okay, while we're waiting for any questions, if people want to go ahead and open up Rstudio and open the R file that I sent you, and please make sure that your R file is easy to find and that .csv, the synthetic mosquito data I sent, make sure that that data is in a folder that's easy for you to find because we're going to need to set it up so R can read that data for you. So if people want to go ahead and do that, I'm going to stop sharing while I get myself set up. And then we'll get started with the R portion in just a minute.
Elle, do you want to give a really quick, like what easy to find means, or like make a folder on your desktop kind of thing, or Karen?
Mhm. I can do it. Yeah, I recommend. So I said this in the email, but I'll say it again here. I recommend make yourself a folder on your desktop named something like Data Viz Summer 2026 or whatever makes sense to you, and put that synthetic mosquito data .csv in that folder. I've written this code assuming you have a folder on your desktop. You can also change the code, but it will be, especially if you're new to R, it will be easiest for you if you go ahead and make yourself a folder on your desktop and put that data in there. Can people see my R screen also? Yes, all the graphs that I showed were made in R. I had to double check with myself, but yeah, I made all of them, including the map that I showed is made in R as well, and using Rstudio. Okay, can people see my R screen? Thank you.
Yes.
Okay, brilliant. All right, we're gonna get started. Hopefully all of you have downloaded Rstudio, have everything set up, and watched the introduction to Rstudio if you're new to it. But just to give a quick, like 2-second overview, and actually before I do that really quick, the way we want to do questions for this portion of the talk is if you have questions or troubleshooting issues, please go ahead and type them into the chat, and Alora is here to help you troubleshoot. And that way I can keep the workshop going while Alora helps you figure out whatever the issue is. So our quick, very fast tour of Rstudio, we have these 4 windows. So you have a window here with your code. We have our console down in the bottom left. In the upper right, we have our environment. And in the bottom right, we have a couple of tabs, but mine right now is set to my files. So this upper left is where I have the code that I pre-wrote for you all. So this is where it should open in your Rstudio as well. In the console, you'll see as we run code, the code will appear here. This is where R is working on your code. As we save things like save our data set, they will appear in your environment here, so you can take a look at them at any point. And then down in this bottom right, you can click through your files if you want. And then also plots will appear on this plot tab once we start running them. So looking at our code, you'll see I've written for you a title for our code, and then I've written authors. So if you want to go ahead and put your name after mine, because you are now also going to be an author of the code. This is best coding practice, so you can keep track of who's contributed to code, what that code is for, and then I've also included this last updated line here, which we can all update to August 14th. And again, this is a great way to track when and who is working on a piece of code. And we'll start with downloading packages. So packages are collections of useful commands we can use that very nice, smart people on the internet have written for us. So if you've recently downloaded R, updated R, or don't recognize these 3 packages here, tidyverse, psycho, and GG themes, what you should do is delete this hashtag at the beginning of the line, and then we're going to run the line. So to run a line, you can click in a line, and we can click this button run in the upper right. Mine is going to ask me to restart R because I've been bad about updating it. Yours probably won't. The other thing you can do to run a line is you can click in the line again, make sure your cursor is in that line. And on Macs, you can hit Command Return. And on Windows PCs, you can hit, I think, Control Enter. Either one of those works to run a line of code. And you'll see once I've run this line, install.packages tidyverse, R works on it here and then lets me know that my package is downloaded. So you're going to go ahead and do that for each of these lines, delete the hashtag, and then run each line to install your packages. I'll give you a second to do that. And if you're unfamiliar with code, this hashtag that turns the line green, that's telling R that that line is not a line of code. So it's a way that you can add notes to yourself or to other readers. You'll see I've added notes throughout using this hashtag. Or it's a way to hide a line of code so that R doesn't run it, but you might want to save it for later. So once you've installed your packages, we also need to load them into R or tell R we're going to use those packages this time. So go ahead and run each of these 3 lines here. So I'm running library tidyverse, library psycho, and library GG themes. And once you've run those 3 libraries, the next thing we need to do is set a working directory, which tells R where the data is that you're going to have it load and where it should save anything that we make. So we'll save a plot later. And this is going to identify to R where the folder is that we're saving. And this command setwd stands for set working directory. And you'll see that this is why I suggested you put a folder on your desktop. So I'm telling R, please go to my desktop and then go to this folder that I chose to name dataviz_sum26. If you named it something different, you can go ahead and delete this after the backslash and type in whatever you named that folder. And once you have that, we'll run that set working directory line. And if you're having trouble with that line of code, the other way to find your folder is to click through your files here on the bottom right. So I would scroll down and go to desktop. I'd click desktop. I'd click dataviz summer 26. And then once I'm in that folder, I can click on this gear and click set as working directory. And that will do the same thing and set that folder as our working directory. And great. Alrighty, if people could give me a thumbs up in the chat if they were able to get their working directory sorted out. Because we need that to work for the rest of this to work. I have a thumbs up from Dalton. How are other people doing? What button is the run? Run is in this upper right here where I'm circling with my cursor. So upper right above your code. Or you can hit Command Enter on Macs or Command Return on Macs, sorry, or Control Enter on Windows. If you don't have any of the packages, you'll want to run these install package lines. All right, Elle and Dalton have that under control. So I am gonna keep going. And remember, this code is all available for you to run later. Also, if you get lost. The next line of code that I'm gonna run is this read.csv. And this is me telling R to take that data file in our working directory and read it into R, into something called mosquedat or mosquito data. And once I run that line of code, again, making sure my cursor's on the line and clicking run or hitting Command Return or Control Enter, R will read that into the environment in our upper right. So I can now actually click on it and we can see our data appear. And so we can take a look and we see we have columns for trap site ID. We can look at the trap type, the collection date, the number of nights the trap was run, the temperature that day, the species that was caught, and then the number of mosquitoes we caught of that species. And I can click this little X to close this so that I can go back to my code. And these two lines I've showed here are ways for you to take a look, just like a quick glance at your codes. If you click line 33, head mosquito data, and you click run, it lets us look at the first 6 values in the data set just to take a look. And STR, mosquedat, stands for structure. And if we click that line and click run, we can look at a list of all the variables in our data set and then look at the types of data we have. All right, so everyone hopefully should be getting to a point where you have mosquito data or mosquedat read into your R. So we're gonna start with a histogram plot. We're gonna make the same plot I showed you all on slide 5 of the slide deck. We're starting on line 52. If you look on the left, you can see each line of code gets its own number. So for building a ggplot, we start by giving R the command that we should use ggplot. That's this right here. We tell it what data we're going to use. So data equals mosquedat. And I've used filter to tell it I only want to look at Culex dorsalis for now. We then have our aesthetic command, which tells R that on the x-axis, I want to look at the total number of mosquitoes. And then once we've told ggplot what data we're using and what variables we're using, we need to tell it what kind of plot we want to run. And for that, we're using geom commands like geometry. And that tells ggplot what kind of plot we want to make. And so I'm telling ggplot, please use a histogram geometry. So to make this plot, you can click on line 52 and click run. And what should happen is in this bottom right, a plot should appear in your plots tab of a histogram of the number of Culex tarsalis females caught. And now if we want to change the plot, if instead of looking at a histogram, we want to look at a box plot, all we need to do is change the geome. If you scroll down to line 58, this is the same code that I wrote for the histogram plot, except I'm now using geome box plot instead of geome histogram. And if we now click in ggplot and then click run, R has swapped it out and graphed for us a box plot instead of a histogram. I'm going to go ahead and rerun that histogram here. So next thing I want to talk about, we've made a histogram. It's there, we can look at it, but it's not very nice looking. And there's a couple of issues with it. So based on the slide deck we just went through, what do you think we should change about this plot? Is there anything we can do to make it easier to look at or better to communicate with? And you can go ahead and type into the chat any suggestions you have to make this a better plot. And if you haven't managed to plot it on your screen, you can look at my screen to take a look at what the plot looks like right now. Dalton suggests we could add some lines to separate the bars. I completely agree. The bars kind of all blend together right now. Is there anything else going on that we talked about? We talked about using color. We talked about labeling our axes. We talked about making a plot sort of clean and not have too much extra information in it. So is any of that relevant for this plot? We could look at separate species, totally. We'll do that in a little bit. Right now, we're just looking at Culex tarsalis, but I completely agree that would be a useful thing to do. Okay, so if we scroll down again to line 66, we're going to look at a couple options to make our plot better. So these first three lines are the same lines that we just ran, making a histogram. And with ggplot, you can start to add layers in order to tweak details about the plot. So if I add this labs command on line 69, that lets us label our axes and add titles and captions. So if I run this plot right now, so click on ggplot and click run, you'll see that my labels are all with a bunch of question marks, and that's because I want you to fill these out yourself. So can anyone suggest to me what we might want to put on our x-axis for this plot? I'm going to remember that we're looking at Culex tarsalis mosquitoes here. So what might be a useful label for our x-axis? So because we're looking at a histogram of one variable, we see, yeah, so I would say that's more of a title. So Dalton suggests frequency of Culex tarsalis trap count. I would say that's a title for this. I'd say for the x-axis, I would want to say something like Culex tarsalis females per trap night. And all I've done is replace those question marks in the quotations with the title I want the x-axis to have. And if we run this plot again, you'll see that my plot has now updated to have that new x-axis title. And we can do the same thing with the y-axis. I'm going to say something like frequency. And then for the title, I'm going to say exactly Dalton's suggestion, frequency of Culex tarsalis females per trap night. And if we again click ggplot and click run, And then look at our plot in the lower right. You can see we've updated our axis titles to exactly what we've typed in these quotation marks here. And one other thing I've added to this code is this last line, theme classic. Themes are a tool ggplot uses to control visuals other than your data that make the plot look and feel different. I'm a big fan of theme classic. What it's done is gotten rid of that sort of muddy gray background and given us really clear and crisp black X and Y axes. So it makes it really easy to look directly just at the data and not have to filter out all the information from that gray background. And the last thing I'll do to update this plot is add color to it. And so again, we have the same code that we've been running now on line 75, but I've added two things. Inside geohistogram, I've now added color dark blue, which is going to turn the outlines of the bars dark blue. And I've added fill equals light blue, which is going to fill in or color in the bars light blue. So I'm going to update our axis titles that we came up with. And then if I click ggplot and click run, we've now updated the plot to have those lines between the bars that Dalton suggested, and then to be filled in with light blue. I think since I have 5 minutes left, Olivia, should I go through one more plot or like sort of go through and show what the rest of the code available to them is?
I think going through what the rest of the code is would be helpful.
Yeah.
And then folks can follow along with the recording too. I'll get that to you ASAP.
Yep, so the recording will be available for you to follow along later. But just to give you an idea, the rest of the code, I've written code much like I wrote for the histogram plots, for several other plots from the slides. So we have a scatter plot, which lets us look at two variables. So you'll see we've changed, and instead of looking at just one variable in the aesthetics, we're looking at two. And I've gone through ways to make that a nice looking plot as well. Earlier, someone in the chat suggested maybe we want to look at multiple species in the same plot. And to do that, we use something called facet wrap. So I've given an example of that lets us look at a plot across different species. I've shown how to do the bar charts from the slide deck, as well as how to make those look nice. The code also includes demonstration of how to use different color scales, like the Psycho color scales I recommend. Also, if you scroll all the way to the end, or almost all the way to the end, I have example code for how to save plots, which will let you actually save plots to your folder that you started. Some example code for putting plots together using a package called Patchwork, which actually I think this is extra code, which I will provide you in the follow-up email. And then I have bonus material. So all of this is basically example plots that you can go through. And the point of this is to give you a resource you can pull from as you go to make your own plots. You can look back at this and tweak these plots to use and work with your own data. So I've given examples of all the different plots that we covered in the slide deck. So if you ever need to make a scatter plot or a bar plot or something like a categorical box plot, you can come to this code, grab the code that I wrote, and then tweak it for your needs. And all that way at the end, I added bonus material, which shows you how to make a simple map in ggplot as well. And Elle says in the chat, Patchwork is a lifesaver, and this is totally true. Patchwork lets you put multiple plots next to each other really easily. It's like magic. I love it. And also in the chat, Elle has added the definitive ggplot textbook. And maybe in the last 2 minutes, if there are any big picture questions people have, we can go over. I'm sorry we didn't get through too many of the plots in ggplot, but all this code is available to you. And you should all have my email as well because I emailed these resources to you this morning. So feel free to follow up with me. I'd be happy to answer questions or troubleshoot anything in this data or anything in this code for you. So any last questions in our last minute, and then we will wrap up. Okay, I think seeing no questions, many thanks to Laura or Elle who did troubleshooting in the chat. I really appreciate it. And thanks to all of you for joining. Like I said, my email is available to all of you from your email this morning. And we'll send a follow email with the recording and with some extra code that I added after I sent you all the resources this morning. So thank you very much.